Find the radius, r, of the inscribed blue circle in a quarter circle. Line constructions, Pythagoras theorem, arithmetic and algebraic operations are used to solve this question. Solution. Label points N, M, and T. Locate the center, O, of the inscribed circle. Join line M, N through O. Also, join line O, T equals R. O, N equals O, T, which equals to R. This implies that O, M equals 7 minus R. Using Pythagoras theorem in triangle M, O, T. The square of line M, T equals the square of line O, M minus the square of line O, T. Substitute values. We have that the square of line M, T equals the square, in bracket, 7 minus R, minus the square of R. We call it equation 1. Label points G, W, and P. Join them, respectively. Also, join line O, W equals R. It follows that line G, W equals line M, T, and line G, T equals line W, M. The reason is that opposite side lengths of a rectangle are equal. Hence, the square of line W, G equals the square of line M, T, which equals the square, in bracket, 7 minus R, minus the square of R. Using Pythagoras theorem in triangle G, O, W. The square of line O, W equals the sum of the square of line O, G and the square of line G, W. Substitute values. It signify that the square of R equals the sum of the square, in bracket, R minus 1, and the square, in the bracket, 7 minus R, minus the square of R. Expand brackets. This implies that the square of R equals the square of R minus 2 times R plus 1, plus 49, minus 14 times R, plus the square of R, minus the square of R. Simplify and combine like terms. We have that 0 equals the sum of negative 2, R, and 1 plus 49, minus 14, R. It follows that the sum of 2, R and 14, R, equals the sum of 1 and 49. Hence, 16, R equals 50. Divide the equation by 16. We have that R equals 50 divided by 16, which equals to 25 divided by 8. Therefore, R equals 25 divided by 8 in units.